Hello, Math BH. We are going to talk about quadratic equations today. We've talked a lot about linear, and today we're doing quadratic. So you should have out your lesson 7.2b, the PDF, where you're doing electronically, or you have out a lined piece of paper. The Steel Dragon in Japan was built in 2000 and is one of the longest and tallest roller coasters in the world. Use the function h equals 400 minus 16t squared to determine the height of the steel dragon as it falls from a tall drop. The variable h represents the height above the ground in feet, and the t represents the time the roller coaster has been falling in seconds. So here from the equation, we can see that it's starting up at 400 feet above the ground, and it's falling. This has to do with gravity. It's falling at a certain amount, a rate due to time. So we're plugging in our values. So when time is 0, when you start, you are at 400 feet. Okay, so after 1 second, we're seeing where we're going to be. So where the t is, we're going to plug in 1. So we have h equals 400 minus 16 times 1 squared. So 1 squared is 1. 1 times 16 is 16. 400 minus 16 is 384. So we know we would be at 384 feet, and that was after 1 second. So that is the point 384. So I want you to pause the video and go through the same procedure and fill in the table for 2 through 5. All right, check your work. At 2 seconds, I'm at 336 feet above the ground. At 3 seconds, we're at 256 feet above the ground. At 4 seconds, we are at 144 feet above the ground. At 5 seconds, we have hit the ground. So now we're going to go over and we're going to plot our ordered pairs. So we know at 0 seconds, we are at 400. And then at 1 second, 384. This looks like it's going by 25s. So a little bit above 75. Okay, at 2 seconds, we are 336. At 3 seconds, we're at 256. At 4 seconds, we're at 144. At 5 seconds, we were at 0. I like to pick another color so that my blue ones don't go all the way, and I see that I am going kind of an upside, half of an upside down U, half of an upside down parabola. Okay, after how many seconds does the steel drag reach the bottom? Well, it's hitting 0 height at 5 seconds. So I would say at 5 seconds, it reaches the ground. At 5 seconds, the height is 0 feet. All right, next question. Determine the average velocity of the steel dragon by using the function velocity equals change in height divided by change in time. So we have to figure out the total change in height. How high did it start at? It started at 400, and how far did it go down to? It went all the way down to 0. And that did it in how many seconds? So it went from 0 to 5 seconds. So our change in height is 400 because we took our initial height, 400, and then our final height, 0. And when we subtract that, we get 400. Our time, we went from 0 to 5 seconds. It's okay that we have negative. It's good because we're going down. If it was positive, we'd be going up. So here we get negative 80. Okay, so the roller coaster's drops at a velocity of 80 feet per second. So we would type that in. It's a drop of 80 feet per second. Now when you're in the roller coaster and the wind's hitting your face, that is pretty fast. Okay, next. The equation h equals 400 minus 16t squared represents a quadratic function. A quadratic function can be described by an equation in the form y equals a parentheses x minus h squared plus k. In the quadratic function, the greatest power of the variable is 2. Graph the quadratics as a parabola. Now we've seen a little bit this. We saw this in linear. Remember, a affected the slope, so how fast it curves up or down. H was the horizontal movement, so the bottom of the U, is it left or is it right? And K was the vertical shift, how far it's up or how far it's down. So we can kind of look at the function and know what's going to happen. So right now we're going to depend on a table, but later on we don't have to depend on a table. So this is our parent function. I like to call it the mother function. This is the parent function. We're going to plug it in. This is the most basic quadrilateral you can have. There's nothing fancy to it. There's just the y and the x squared, and there's no kinds of shifts on it. It is our parent function. So here we're just squaring. 2 squared is 4. 1 squared is 1. I need my pencil. 0 squared is 0. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. And we're plotting. We get our basic U shape. Okay, this is our parent function, our most basic quadratic function or parabola. That was not a good U. Let's try that again. Okay, so here, think about it. Think about it how we did shifts before in our section. The negative, what is that negative going to do? It's going to flip it upside down. So instead of being right side up, it's going to be a sad face, upside down. The plus 4, that's a vertical shift. It's going to bring the point at the bottom and it's going to bring it up 4. So this is going to go up 4 and flip upside down. All right, let's check if we're right. Negative 2 squared is 4. Make it negative. So this is negative 4 plus 4, which would be 0. Negative 4 plus 4, which is 0. 1 squared is 1. We got to make it negative. So this is negative 1 plus 4. That would be 3. 0 squared, 0. 0 plus 4 is 4. Negative 1. Negative 1 squared is 1, but we got to make it negative. So this is negative 1 plus 4. We're back to our 3. Negative 2 squared. Negative 2 squared. Negative 2 times negative 2 is 4. Make it negative. Negative 4 plus 4. We're getting back to our 0. Okay, so I'm putting a point at 2, 0. At 1, 3. At 0, 4. At negative 1, 3. And at negative 2, 0. And then I make my little graph. Okay? Remember, I said this is going to make it upside down. That negative makes it upside down. That 4, that was a vertical shift up. This 4 made it go up. So this went up from the origin. It's up 4, and it got flipped upside down. All right, next one. The graphs are symmetric along which line? So what line is cutting these shapes in half? Now mine are very sloppy, but if you drew them neatly, the y-axis would be cutting the parabola in half. The y-axis is the axis of symmetry. Okay? Explain in words how symmetry is shown in the table of values. Well, we start seeing the y values repeat. So like here, there's a 0 and there's a 0. Here's a 3 and a 3, and there's the 4. So we know the 4 is the middle. Here's the 4 and the 4, the 1 and the 1, and we see the 0 is in the middle. So the y values start repeating. Why does a symmetry occur? Well, because when you square a negative and you square a positive, you get the same value. So 2 squared is the same as negative 2 squared. Squaring a negative or a positive gives you the same value. So you'll see later on in math, when you have an even exponent, if this is a 2 or a 4 or a 6, there's going to be some kind of symmetry in your graph. If it's a 1 or a 3 or a 5, you don't have the same exact kind of symmetry. Explain in words how the graph y equals negative x squared plus 4 compares to y equals x squared. So the negative flipped it upside down, and the 4 was a vertical shift. The negative one made it reflect down, and the positive 4 made a vertical shift. Okay, so here, pause the video, try. What do you think is going to happen between this graph and this graph? Take a shot at it. Okay, so I put the 1/2, makes it less steep because now it's not really slope anymore, it's acceleration, but it's accelerating slower. And the -3 is going to make it shift down 3. All right, so let's actually try out the values and work them out. So 2 squared is 4, half of 4 is 2, and 2 minus 3 is -1. Okay. 1 squared is 1, half of 1 is a half, and half minus 3 is -2.5. 0 squared is 0, and 0 times a half is 0, and 0 minus 3 is -3. -1 squared is still 1. 1 times a half is a half, and a half minus 3 is -2.5. -2 squared is 4. Half of 4 is 2, and 2 minus 3 is -1. Again, look, I see my symmetry. These are symmetrical. These are symmetrical. That means this is going to be my vertex, and it's dropped down -3. Plot your points. At 2, I'm at -1. I'm also at -2 at -1. At 1, I'm at -2.5. And at 0, I'm at -3. Oh, I didn't do those 2 points right. I need to come down a little bit. -2.5 would be down there. Okay, so we're curving out over here. Okay, less steep and shifted down. All right, next one. Let's see. What is that 3 going to do? It's controlling the acceleration. It's bigger than 1, so it's going to make it steep. It's going to make it accelerate fast, and this is going to take the vertex and push it up 1. Let's try it out. 2 squared is 4. 2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. 1 squared is 1 times 3 is 3 plus 1 is 4. 0 squared is 0 times 3 is 0 plus 1 is 1. -1 squared is 1. 1 times 3 is 3 plus 1 is 4. -2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. Again, I see my symmetry. So at 2, I'm at 13, which is off the graph. That's okay. I can kind of estimate. 11, 12, 13. Really steep, huh? Same thing at -2. At 1, I'm at 4. At -1, I'm at 4. At 0, I'm at 1. So this is, don't make it a V shape. It's a U shape. It's a really skinny U. This shifted up 1. Okay, so parabolas. Now we're looking back. We've done all 3 of these types. This was linear. This is quadratic. And this one is our absolute value. So I want you to go ahead and graph those 3. Be neat. And then find where they intersect. Once you have finished, come back and check your work. All right, so I plotted this one and I got my line with negative slope. And I plotted this one. This is my upside down parabola. Looks like a U upside down. And I plotted this one and I got my V. And I want to know, where do they all cross? And I see that they all cross right here, over here at 1, 6. That's where they're all crossing at the same time. So I put 1, 6 for my intersection. Then I had to verify it. So I had to plug it in and show my work that both sides equal. Here, both sides are equal. Here, both sides are equal. So I know that that point makes all of my equations true. That's why it is the point of intersection for all 3 of them. Okay, we're done with this lesson. You're ready for your homework. I'll see you next time. Bye.